I'd like to show you this nifty little circuit that I made right here. It's just a super simple voltage divider that powers the gate of a P-channel MOSFET. But what this lets me do is switch the power or the voltage going through this little LED here with the flip of a switch. So if I have a 5-volt bus voltage, I don't turn on my LED. But when I've got 3.3 volts, the LED turns on. Now, you might wonder where this is useful, and the answer is right here with the CH340. This is a little USB to Uart converter IC, and you can see that it's got this VCC and this V3 line. And if we look at the pinout in here, this V3 line should be connected to VCC when VCC is 3.3 volts, or connected to a 0.1 microfarad decoupling capacitor when VCC is 5 volts. Now, I've tried to just connect this to a 0.1 microfarad decoupling capacitor, 100 nano, but it doesn't work. It doesn't actually turn on. It only works in 5 volts then. So that's where this circuit comes into play. I've got a little switch, and when I flip it to 3.3 volts, I supply 3.3 volts to the input pin of this IC. And when I need to use it in 5-volt operation, it removes that voltage from that pin. You can see if I check here, there is still a little bit of voltage, but it's not enough for it to matter. Could I pump 3.3 volts in all the time? Maybe. I don't think I've tried it, but this works and is fairly cheap. This is just a 1-to-1 voltage divider right here, but something you do need to be careful of is that your MOSFET needs to have a fairly low threshold voltage. The one that I found does not have a typical voltage, but its max is 1 volt, which works out okay, and the min is 500, which does allow a little bit of voltage and a little bit more current than I'd like to flow through, but it's just low enough that it should still work out. So I've made this little board, and it works out great. It's a super tiny little UART to USB converter, and it's got a little slide switch on the side of it, and you can slide that from 3.3 to 5 volts to select the bus voltage that you want to work with. Oftentimes, when we're working with things, we've got Arduinos or ESP32s or whatever that may be, and sometimes you need 3.3 volts and other times you need 5. So this guy right here is easily selectable. It sets the logic levels on the lines, and it works out great. Now, you might wonder, why would I make this when one of the little red ubiquitous FTDI boards exists? It's the FT232RL. And the answer is because the 3.3 volts on these boards really sucks. It's not enough to power an ESP32, but when you're trying to use Wi-Fi, the chip just browns out every time it tries to turn on. So my board implements an actual linear regulator that is capable of supplying 600 milliamps. So my board will kick on an ESP32, no problem. You've also probably noticed that there's this little jumper right here, which allows you to set 3.3 or 5 volts, which works, but it's just inconvenient compared to the switch. I've also found that with this switch, I can just slide it from 3.3 to 5 volts, and it hot changes. Just right then and there, it'll switch from 3.3 to 5 volts. No questions asked, it doesn't even disconnect from my computer. So I'm curious, is this something that you'd be interested in? Do you want to own one of these? Does it have any value to you? Let me know. There's also a slightly larger version that might make more sense depending on what you're doing, which is a built-in USB hub with 4 of these built in and one extra feature: full fat RS232 serial. RS232 is a bipolar bus, perhaps. A negative voltage corresponds to a 1, while a positive voltage corresponds to a 0, unlike traditional UART, where a ground or 0 volts corresponds to a 1 and 5 volts or 3 volts corresponds to a 0. Additionally, RS-232 has a wider range of voltages. It works in the range of 3 to 15 volts. So this board has 4 of those, and they're all selectable with a switch. So you can set 5 volts, 3 volts, or you could use RS-232 if you need that in your application. I don't know. Let me know.